Apple. He's the COO, and I do get quite a lot of marketing calls of people trying to sell me stuff directly as the COO of Apple, which is, my kids think is funny because I string them along a little bit. Okay, hey, thanks everybody for coming out. So I'm going to talk a little bit about a different way of thinking about application security. So for the next 30, 40 minutes or so, I want you to forget what you know about how you go about finding vulnerabilities by either looking at code or using automated scanner or doing pen testing or however you do it. I want to introduce you to a new technique that we've been using very effectively for a number of years now. So I think you gave most of my background. I did get involved with AppSec really early. I've spent the last 20 some years working in AppSec. I helped to start OWASP. I love seeing chapters like yours that are super mature, super set up, helping a lot of people with, I saw the what do you call them, tutorial sessions. I mean, it's just doing a whole bunch of really fantastic stuff. I started the chapters program back in about 2003. And at that time it was just, we had 200 chapters or something around the world, but it was just very early days. We were trying to figure out how to help people best. So it's fantastic to see how far they've come. So please, this is this should be interactive. I'd love to take your questions as we go along. I'm going to bring up the chat window here. So if you have a question, please do post it and I'll try and take a look at that as I go. So let's jump into it. So I always try to start talks with some facts, and frankly, most of you are probably familiar with this. I don't think we've made a lot of progress in AppSec over the last 20 years. And I hate to say that because OWASP is a great organization. I feel like we've contributed a lot to the world, but at the same time, I got to look at the numbers. And frankly, most applications have a couple of dozen vulnerabilities. They've got some library issues. They get attacked 13,000 times a month. They're introducing new vulnerabilities at a pretty good clip, 2 or 3 a month. All those numbers are basically what they were back in the early 2000s. And so I feel like even though we have made slow progress at OWASP, I feel like the software world has accelerated even faster than that. And so there's a gap that continues to increase as we go forward. If you're interested in those kind of stats, you can look at this report that we created. A bunch of different vendors do this. I think ours has some really good data on both vulnerabilities and attacks. Because we collect both of those things, we can kind of put them side by side and say, hey, what are the really serious things? What are the most prevalent vulnerabilities and which ones are actually being attacked the most? So it's kind of a unique view. So let's talk about instrumentation. So instrumentation is any kind of measurement that you put directly on something so that it measures what's really happening. Many of you may be wearing, things like Fitbit or Oura rings or Apple Watch or whatever, that's actually measuring your body directly. And the insights that you can get from those things are fantastic. In some cases, you can see problems before they exist. So for instance, with the Oura ring, which I just started wearing, which is this thing, it's kind of fun. It measures your pulse and your temperature and your breathing rate and when you're sleeping and so on. And I was hoping to get a little feedback on sleeping so I could sleep a little better. But the idea here is this thing will know if I get COVID, it'll alert me early because my temperature will change and my sleeping patterns will change. That's kind of neat. I go to the doctor once every 4 or 5 years and only when I'm sick. So I don't have anything that's looking at me continuously and monitoring to see if anything's going haywire. I think that's a really valuable thing to have. So that's what instrumentation can do. And instrumentation changes whole ecosystems. Let me give you an example of this basketball. So this is a 9450. It's an instrumented basketball. It's got sensors in it that detect your dribble speed, the rotation on your shot, the arc of your shot, makes and misses, a whole bunch of other things. It also comes with an app that gives you a bunch of drills to try to help you improve your skills. And I was a little skeptical. I've been playing basketball for a long time. If you ever meet me, you'll know why. And this thing really helped me. I was shooting the ball way too flat. And I started using this thing and getting that instant feedback, and it really helped me improve my game. I like the idea of measuring things directly and getting that instant feedback. And the accuracy is like a kind of a different level because it's measuring what I'm doing directly. Now, when you think about the big picture of some market, like let's say healthcare, if we were all instrumented for health reasons, we could do much better public health efforts. We would know where to target our interventions in the world to try to deal with diseases before they break out. You know, with COVID, we tried to do a lot of testing, but it's really difficult. Not everybody wants to take it. It's a pain in the ass. And so it was very difficult to get accurate measurements, but instrumentation can help. And with the basketball, for example, imagine if kids could get really pretty good coaching without a coach, just with the ball. They could improve their game a lot. The role of the coach might actually change, right? Instead of having to be there every minute with the kids and sort of coaching to the lowest common denominator on the team, instead, coaches could look at data, teachers could look at data from across a broad time frame and give individualized feedback to folks when they need it, much more interesting, actionable feedback than just sitting through a generic class designed for everybody. So I like the idea of instrumentation in general, because I think it changes the dynamics of markets. And ultimately, that's what we need to do in AppSec, but that's a different talk. Here, let's just focus on instrumenting software. And the good news here is instrumenting software is easy. We've been doing this for 20 years for various purposes. Sometimes it's logging, sometimes it's measuring performance, sometimes it's testing. But we can instrument software at runtime, so we don't have to change anything about the way that the code is written or built or tested or deployed. Instead, you can add this instrumentation as the code starts up. And as you see in this picture, basically what's going on here is you have the original code that's on disk, binary code. And as it gets loaded into memory, instrumentation engines give you a chance to do various simple transformations to that code. You can add sensors to what you want to kind of listen into. And then what runs is this instrumented code. So instead of having an exact copy of the code in memory, now you have this instrumented code that's got sensors on things that you care about. Maybe it's calls to SQL exec. Maybe it's get parameter calls. Maybe it's whatever you care about that you want to listen in on. You can run this instrumented code and get feedback on how the application is working. So let's think about how we might use that from a security point of view. Traditionally, when you do pen testing, you send attacks to an application, and then based on the HTTP response, you try to decide if you did something interesting. Sometimes you may do something interesting and not recognize it. Other times you may crash the application and you'll see the response, but you're blind as to what's happening inside the black box, because who knows what's going on inside there? There's no way to really tell. I used to do code review and pen testing at the same time, so I could send in an HTTP request, and then I could look in the code and I could try to trace out what was happening. And it's really, I don't know, for most people, it's not very exciting work. I kind of enjoy it, but I'm weird that way. But you have to do a lot of forensics to try to figure out what the code is actually doing with each payload that you send in. And then eventually you get this response back, and using that, I would try to figure out interesting vulnerabilities. And I was lucky to have found a whole bunch of really interesting kinds of vulnerabilities over the years. But imagine if we could instrument the application. Here, imagine this guy here is inside the running application, and you can tell this person to look for whatever you want. Now, when you're pen testing, or even when you're just doing normal development, you're interacting with the application and you can get feedback on what's going on inside the application. So you can see exactly what you care about. Like if you want to know if there's SQL queries or expressions being evaluated, or XML documents being parsed, or runtime exec happening, whatever you want to see, you can have your agent inside the application looking for that stuff, and then sending you back really detailed results. Like, hey, there was a SQL query on line 310 of this class, and here's what the query looked like, and here's the the data that it received from that was part of the runtime parameters, and so on. So you can get all this detailed information. It makes pen testing much, much easier. It even enables developers to do a lot of their own security testing. And we'll talk about how this works as we go. I just want to give you the kind of the framework here. But that's really what we need to do. If we want to scale AppSec and actually make progress, we've got to leverage the big machinery of software development to do a lot of the work of application security. There's no other way out of this mess. There's way too much code being written for us to deal with it with the small, limited number of AppSec experts that are available now. Okay, so let's dive in. Oh, I've got a question that says, are you saying that there are apps that do not have vulns? Yes, there are. If you were looking at that slide a few slides ago, there's something like, it says 96% of applications have at least one vuln. Some apps don't. Usually they're really small. They're like serverless functions or APIs or something that's really, really tiny. So we're going to look into how we use instrumentation to inform our application security testing and make it much more accurate, much faster, much more cost effective. And I love this idea of looking at the runtime reality. As AppSec has evolved, I think the idea of looking at the code with either static tools or even manual code review gets harder and harder, because less of the code is, less of what is actually running is actually in that code. There's lots of functionality that comes along in like a serverless environment or in a framework or a container that adds a ton of functionality to an application that's not in the source code. You can't figure out where the vulnerabilities are because you're only seeing a piece of the application. So I think looking at the whole application as it's really assembled in a running environment is really today the only way of doing adequate application security testing. All right, so we're going to use a tool called JOT. This is the Java Observability Toolkit, and it's a simple instrumentation framework that allows you to create new sensors without writing any code. And that was my goal when I created this project, was to make it really easy for anybody to instrument an application and find out really interesting information. Instrumentation is not that hard, but it does require some pretty deep programming experience. Writing code that instruments other code takes a little bit of knowledge and experience. So I tried to make it really easy. And using JOT, you can create a YAML file that specifies, say, a method that you want to spy on or some data that you want to extract from a method, and it makes it super easy. So I think of it really like this diagram. I think of it like putting some probes into the application and then listening to the application as it runs, and you'll get readings, events off of the application that you can interpret. Let's take a look at a really simple example. So this example is an example of understanding the attack surface in an application. Actually, before we do this, let me start with an even simpler example. I'm going to show this live. So this is a ticket book. This is a really simple application that just it's got some simple functionality, but mostly it's kind of WebGo-like. It allows you to test out certain vulnerabilities. So I'm running this normally now, but I'm going to run this with an instrumentation agent using JOT. So first thing I'm going to do is I'm going to tell Java to use JOT, and you set this Java agent flag with the jar file here. This is just a simple jar file you can download from the JOT website. And then you specify the JOT you want to use. In this case, it's this usql.jot. And again, that JOT is just a YAML file. Let's take a quick look at that. This is really simple. All this says is, I want to see unsafe queries. And so we put sensors into these methods. This is the JDBC API. And the only thing that's a little weird here is we have to exclude prepared statement because that's typically not vulnerable, although it is possibly vulnerable. And we're going to capture the arguments from these methods. So that's the parameter. The parameter of these methods is the query itself. So we're just going to capture that. And this is like if you wanted to find out everywhere in your organization where you're using unparameterized database queries, this would be a good way to do it. So I set my environment variable now. So I'm going to use JOT, and then I run the application normally, just simple starting up Tomcat. And actually, when it starts up, you can see up here, it gives you a little bit of details on the methods that it's instrumenting. So that's as long as it took to instrument the application. It's just like less than a quarter of a second or something. And then after that, the application just runs normally. So as I use this application, I'll register. You can see in the background, JOT detected all the queries and recorded the information from those queries. You can even see the exact method and the exact line of code where those queries are run. You can get the full stack trace actually if you want. These are all go through a database abstraction layer, but we have the full stack trace if you want it. And as I go through this, you can see, I can click on these things. I could type in OWASP again, and you can get a sense like, hey, look, if I'm doing a pen test and I see that when I visit this page, I see that the data I typed in OWASP ends up right in the query like that, I got a pretty good chance that that's an exploitable SQL injection vulnerability. So you can see how much easier that is. I don't need to rely on the response back from the application. I can actually just look and see where the data landed in the query. So look, this is really simple. We're going to get to some more complex stuff right away. So I just wanted to give you a sense of just how easy it is to instrument stuff. So this next example is about understanding the attack surface. And this has a little more complicated JOT file. So here you can see a few sensors. First, we put a sensor on the service method in Java, which is every HTTP request goes through the service method. The first parameter is the HTTP request, that's P0, and we're going to get the URI from that request. So now I know every time a request comes in, I'm going to capture the URI. And then I want to know the tested parameters. These are the ones that were actually sent in. So I'm getting the parameters from the HTTP request. And here, I want to know all the parameters that were accessed by the code, which is a different set of parameters, right? The ones that you send in may not match the ones that the code is actually listening for. And so then you put a simple report, like a table report here, and it just dumps out the routes, and then the columns are all parameters and tested parameters. They just point to these rules. So when you do this, you can see exactly what happened here. And you can see here, for instance, the headers page, we've tested these parameters, but we've seen these are the ones that are being actually used in the code. So there's more parameters being sent in than the ones that are actually used. You can also see the submit buttons. Those are sent in by the application, but they're just the button. But many times you can see parameters here that are not visible through HTTP. Secret parameters, things like an admin parameter or a isAdmin kind of parameter that would allow you to escalate privilege. So this is a cool thing for pen testers to do to understand the attack surface of each route that's exposed, because you can see exactly what parameters are available for each of these. We looked at the SQL queries already. Let's talk about encryption here. This is another great example. So in this case, we can create a JOT that just captures the use of cipher.getInstance. In this case, anytime this application calls cipher.getInstance, which is like the Java cryptography extension way of getting an encryption algorithm, we're going to capture the parameter to that, which is the name of the algorithm. And then you can create a table that looks just like this. You can say, hey, show me where I'm using encryption and show me the exact algorithm that's the algorithms that are being used in that route. And here you can see this is using single des, it's using password-based encryption, it's using, cipher block chaining. It's, you get all the information about the ciphers that are used. And I strongly suspect if you run this on just about any application, you'll get some surprises because MD5, SHA-1, DES, password-based encryption, they're all over the place in throughout your stack. It's just, this is the only way to really get a view at it because a lot of it is in libraries, a lot of it's in frameworks, and a lot of it's in app servers and the platform itself. So this is a cool way to get observability. This shows you really shows you what's actually going on in your applications. And I'll take a minute to just explain the JOT format a little bit more. This capture line where I wrote %p0, in this case, it just captures the first parameter to the getInstance method, but you can use any of the parameters like P1 through P9. You can use args to capture all of the parameters at once in one big string. You can capture the object. So in this case, the cipher object itself here, or you could actually access the return. If this method, returns something, this getInstance, you could get that, in this case, an instance of the SHA-1 algorithm. And then you can call methods on those references. So in this case, I got P0. Maybe I want all these to be lowercase or all uppercase or whatever. I could call a method, I could put pound P0 dot to upper so that they'd always be consistent across everything. So this is a really cool way of getting into a method and then making a couple of hops to get the data that you really want to extract for your sensor so that when you're observing it, you can put the sensor kind of exactly on what you want. Anybody have any questions on this so far? I know I'm going a little fast. I hopefully this is understandable. Okay, well, please jump in the chat if you do have questions. I can see it on my screen. So let's push on. I love this one. Access control is one of the hardest things to verify in applications. I made a career out of testing access control in critical web applications. Like the defense travel system, for instance, I bypassed all of their access controls and was able to take over as admin using the fact that they're just not checking access control very well. But it's really hard to test. If you're a pen tester, I know you know this. It's very difficult to test. So imagine we could put some sensors on all the access control checks in the application and then just use the application normally and generate an access control matrix. So that's essentially what this does here. We'll put a sensor on the get remote user to identify the user that's coming in. We'll put one on any role checks. This is user and role is an access control check in Java. It's built into the framework. And we can put a sensor on it so that we see all the access control checks. And then we can generate a matrix out of that over time. So let's take a look at that. This is a fun one to demonstrate. So I'm going to switch my JOT here to access. And you can combine these JOTs, by the way. You can run a whole bunch of them at one time. I'm just kind of showing them individually, but you absolutely can run them all at once. So again, same deal, just start up and run normally. And I'm just going to click through some of these pages and you'll start to see we're building a test coverage matrix here. And you can see these are the pages that I've accessed so far. And I can keep going through the rest of these pages and you'll see, we're growing our list here. Maybe I can make these viewable at the same time. So these bottom pages have some access control checks in them. So when I hit access A, you can see there's a test to see if I'm currently in role A. If I am, then this test will pass and I'll execute that code. You can see right now I'm logged in as guest. So I'm hitting these pages, but I can see these access control checks. And you can see here, notice that I did click on page D, but there is no access control check in page D. It's up here in the test matrix, but there's no access check there. So maybe that means I can access it with any role. Page E has 3 access checks, which is also possible, but maybe it's a mistake. There's no way of knowing really whether this access control matrix is correct or not without talking to the development team. And this is where you can start getting to what people might call business logic. I don't really think it's business logic, but it's stuff that's very difficult to automate the testing of. But we can automate the generation of this access control matrix. And then it makes it really simple for anybody who understands the business to go on this list and say, well, no, role E shouldn't be accessing page D and so on. I guess the other way around. Sorry, role D shouldn't be accessing page E. Like that's not what we want. We can also use this, I built in sort of quick user switching rather than logging out and logging back in as another user. I made it easy to switch here. So this is kind of interesting to think about test coverage. So I just switched to user A, and now you can see I've tested these pages as user A. If I continue and switch to B, I'll just click on a few of these just to get a sense so you can see the problem here. So let's say I spent a bunch of time testing these applications as a bunch of different users, but I didn't really ever keep track very well. I would never know that I didn't test B, C, D, and E as user B, C, and D. And I really should, because like user C, there's a special check in page C to see if I'm logged in as user C. So I probably didn't really test that page very well if I didn't understand this. So from a pen test point of view, this is really a useful kind of tracking to make observable as you're doing your pen testing, as you're using your application. And actually, a lot of this, I didn't have to test anything. I can just use the application normally. And then I could kind of zoom in on the problems. I could say, oh, if I'm like not logged in as user D, can I access page D? And I could just force browse to, I could just go to page D and see like, oh yeah, look at that. I get a special page. So I really like this, this visibility into the access control page. This would have made my job much, much easier. Taking things that would have taken days or weeks to test down to something that would just be, kind of in the background as I'm doing my other testing. Any questions there? If you're not doing this, I really encourage you to test access control because it's often missed. Yeah, go ahead. Sorry, I thought there was a question. Okay. Let's do a couple more examples. So one thing that you can do with JOT is you can generate diagrams of what an application route does. So in this case, you can see when I send in a request to this, you can see a couple of paths. One goes straight to an expression language injection right away. Another path goes through the code and does a get parameter. You can see the value of the name of the parameter and the value. You can see we actually get that parameter twice. Sometimes that happens in code. Then you can see a query get generated, and it looks like it uses that data from the parameter. And then later on, there's some encryption, and then another expression language. And in fact, that even feeds back into another pass through this code. So interesting flow through this that you can see likely has a SQL injection kind of problem, maybe an expression language injection problem as well. You can do this with just about any sensors you want. In this one, I decided to look at headers. So I turned on those sensors, and you can see this is, for this route, here's what headers get set. You don't have to look at every HTTP response. You can just see exactly what's getting set by the code. In this case, you can see then there's an expression language expression that gets evaluated. You can also see a get parameter and another expression language evaluation. So this path is probably vulnerable. This path uses like hard-coded data, so not vulnerable. Here's another one for a different route. And again, this is just if you're a pen tester, having this blueprint would be just such a great way to shortcut your testing. If I look at this, I can say, well, I really only need to worry about this runtime exec here, and maybe the headers are set wrong or something. But you don't have to worry about SQL injection here, because we're not going to a SQL query during the execution of this route. So that's really powerful. It saves a lot of time and will focus your testing on what matters. I think it's cool that in this case, runtime exec call is here, but underneath the hood, after runtime.exec gets called, there's all this encryption stuff. Like it tries to find the right encryption algorithm. It's all really part of this, creating a socket to get the results from the process that you spawn. But I was surprised to see all this stuff. The application doesn't do this. It's just under the hood stuff that I didn't know happened inside there. Okay, so let's talk a little bit about just kind of workflow. And if you want to read more about this, I wrote an article about it. It's developer-friendly security reporting I put it on LinkedIn. But the idea here is, most security vulnerabilities get communicated to developers in ways that are good for security, not ways that are good for developers. Like you get a PDF report with a ton of false positives, or you get a dashboard that you have to go to and look stuff up in. It's not really the right way. And I think we're getting better at that. There are some IDE plugins that are okay, provided the data is good. There's some, integrations into Jira that are starting to get better. But really, developers want to consume problems in their code just like they consume any other problems in their code, just like non-security problems in their code. So with JOT, you can do that. You can actually have JOT fail test cases if a particular condition is met. So in this case, we just put a method to match on any time you call process builder dot anything, which is under the hood of runtime.exec. So anytime you try to start a native process, you could fail that test case here by adding this scope, which says, hey, if you're inside a test case, then throw this exception. And it just gives the developer a notice. This is, hey, to prevent command injection, our security standard restricts operating system commands within web apps. So let us work with you to find a safer way to do this. And then it fails like right in their environment. It's the way their normal test cases fail. You can see it failed, like this is JUnit, and it failed the actual test case. I think this is really powerful and will encourage developers to fix vulnerabilities right away so they can just continue building their code and committing great code. And this didn't have to go way downstream. It didn't have to, get into a build, get into a test environment, get pen tested, get in a PDF report, get tracked, get risk rated, get eventually remediated and retested. All that work goes away because you just fixed it immediately after it was introduced, because you had the test case failed right in the right place. Let's do a demonstration of this. So you can also use this instrumentation to prevent exploits. This is really what people call runtime protection, or RASP. And so let's take a look at expression language injection. This is really important. This was one of the ways that people exploited log4shell, and it's good to understand it. So this field is, it looks just like a normal field. You'd probably suspect XSS here or something, but actually, if you send the right input, you can make this engine evaluate that expression. See how it returns 2? It's evaluating this as a kind of code. Well, that's pretty powerful. And if you're a hacker, you look at this and say, well, heck, what else can I do with that? So people figured out, like, oh, look, I could call methods. Like I could do like 5 plus math dot max of 2 and 10 and evaluate that. Oh, okay, look, that's awesome. Now I can call methods. And so everybody with me so far? Like the next step is say, okay, well, what if I call runtime, get runtime dot exec open -a calculator. Copy that just in case I messed it up. So you can see pretty quickly, like I was able to take over the app server here completely. And this is roughly the same kind of attack that they used in log for shell, just a slightly different path to get this expression into the application. It went out via JNDI and came back in, but same kind of idea here. And so could we use instrumentation to detect this and prevent it? Well, sure. Let's take a look at a different JOT. So here's a JOT that's basically, it does the same get route thing we talked about. Then this is where the work gets done in this EL sandbox. This says, hey, if we're going to call process builder or create a socket, or you could extend this list to include files and some other things. If you do that inside the evaluation of an expression, like you're inside the scope of the evaluation of an expression, that should never really happen, right? Like your expressions should be simple things like, hey, get me some value out of a bean, or do a simple calculation or something. It shouldn't be like starting processes and accessing files and stuff. So you can prevent all of that from happening this way. And now when I run with this JOT, I'll just put in JOT and I'll run the application the normal way here. Now I can still use my expressions. Like I'm not turning off the ability to use expressions. See, I can still use them, but if I try to exploit it, JOT intervenes and prevents that expression from being evaluated. You can see expression language injection attack detected and blocked by JOT EL sandbox sensor. That's really powerful. I didn't have to change my code at all. And I basically made expression language injection impossible. I ruled out that whole class of attacks. In a way, this is sort of similar to what compiler vendors did with ASLR and DEP back a decade ago when they were dealing with kernel exploits. They made it much more difficult to exploit those vulnerabilities and made buffer overflows much less of a thing. We can do the same thing with web attacks and OWASP top 10 kinds of attacks. You can do this exact thing with all the different kinds of attacks, SQL injection and cross-site scripting and EL injection and unsafe deserialization and so on. So here's a question from Callian asks, hey, if I'm a pen tester or bug bounty hunter, how can I benefit from this tool? Well, you have to have the ability to add this tool to the application. Typically, you can get that if you're working with a company and you're testing their applications, or you're running the application yourself and you're testing that, then you can use this technique, no problem today. If you're testing some other server, you'd have to, some server that you don't own, whether you're a bad guy or a bug bounty hunter that, on a remote host, you'd have to ask them to say, hey, I can find a bunch of vulnerabilities, but you got to add this agent so that I can get more visibility. Maybe they'll agree, because it is much more efficient for you to do your testing and for them to get value by having this kind of visibility. I am working on a way of delivering this so that you can just do it remotely. You'd say like jot-h remote host, enter some SSH credentials, and then it will push the agent into the application automatically, connect and add it, and then you can start getting this data dynamically. But I need to do a little bit of coding for that. Okay, so anyway, that's expression language prevention. Look, here's what we did today. First, we used instrumentation to find vulnerabilities. Gartner would call that IAST, or interactive application security testing. But all that means is just using instrumentation to find vulnerabilities. You can use this in dev and in test. It's easy and will improve your testing dramatically because it's so much more accurate. In fact, in a lot of cases, you don't even need a pen test. You can just use IAST with an application and just do your normal development and testing. And IAST can find vulnerabilities without exploiting them, which is really powerful, because then you can use that big machinery of development to do most of this work. We also talked about using instrumentation to detect attacks and prevent them from being exploited, like we just did with expression language injection. That's RASP, Runtime Application Self-Protection. And every application out there and every API should be using RASP. It's an incredible way to make whole classes of vulnerabilities much more difficult to exploit. SQL injection, all the bad vulnerabilities, file path and traversal, and so on. So you really should add it. It's incredibly high performance, which is like sub-millisecond performance to add this, because this instrumentation is woven right into the code of the application. It's not like an extra network hop or anything. It doesn't have to reparse the HTTP request. It's just an extra, it's like literally like you coded that extra check right into that method. That's what the resulting bytecode looks like. I think this is a big shift. It's how we move from this legacy outside in scan and firewall model, where we're trying to do AppSec with limited context. We're making a lot of mistakes, which means we need a lot of experts. We can move to an inside out model, an embedded model for AppSec, where we're doing the analysis inside the running application. This way we can be much more accurate because we have a lot more context. You can leave it there always, like it should just always be on, always testing your application in case you step out of bounds, instead of running a test every once in a while. And it's scalable. Like imagine all of your applications, hundreds or thousands of applications and APIs out there, wherever they are, you don't care. They're all testing themselves and reporting results to a central server. That's really powerful. That's a different way of thinking about AppSec scaling, instead of just having to go one by one through a list and then start over again and scan again. Ultimately, what we want to do is we want to accelerate the delivery of secure code into production. That's this flow of getting functionality, delivering value into production. And using instrumentation, we can do that. We can instrument the application with IAST and RASP. You can even do SCA this way, by the way, to analyze your open source use. It's a lot more accurate because you see exactly what code is used and which libraries aren't used. But anyway, you get this feedback directly from the application. You get very tight feedback loops. So developers can just fix vulnerabilities without a lot of hassle, check in clean code, and continue pumping value into production. And then in production, you get visibility into who's attacking you, what kind of attacks they're using against you, protection against those attacks. And you can feed that threat intelligence back into development so that they understand the severity. And the average, I said at the beginning, the average application gets attacked 13,000 times a month. Well, that's great motivation for developers to fix vulnerabilities if they're accurate and if they know they're being attacked. So I encourage you to create that short feedback loops with vulnerabilities and feedback loops from production back into development so that they can really appreciate what's going on. To me, this is the essence of DevSecOps, is getting this machinery working so that ultimately you work off your backlog, and then as new vulnerabilities get detected, you fix them right away and you stay healthy, instead of kind of, a lot of organizations I see, they carry a big backlog, they wait, and then maybe once a year they clean it up in order to be compliant for one day. And then right after that, they start introducing new vulnerabilities and they build up another backlog and they're out of compliance most of the year. That's really not what I was thinking of when I helped start OWASP 20 years ago. So here's some metrics that you should focus on. If you're not measuring these things, you really should, because they're the best way of understanding what your AppSec program is actually achieving. The first is mean time to remediate. And this chart is based on data from various vendors. It takes with DAST, it takes 320 some days to get to median remediation. With SAST, it takes 290 days, the latest report, to average remediation. That is way too long. IAST is much better. IAST is under 8 days for most applications. That's a massive improvement. This is what will allow you to quickly improve and quickly get code into production. So I think MTTR is like the best metric of how fast your feedback loops are. But vulnerability escape rate is another really useful metric. This is a measure of how many new vulnerabilities you're introducing per month. And what you want to do is reduce that. Because even if you're finding and fixing them quickly, if you're introducing 5, 6, 10 vulnerabilities a month, you're wasting a lot of time. It would be better to not introduce those. And then you save all of that time. So I encourage you to measure how many new vulnerabilities you're getting each month and try to drive that down. We've seen with IAST, we've gotten in about a year, we can get VER down to less than one new vulnerability a month, which is really, I think, pretty healthy. Sounds manageable to me. So those are two metrics that I highly recommend. And I'll just finish up here with some links to a couple articles. This first one is called How to Vulnerability. And it's really about how do you communicate vulnerabilities that you find to the people that need to know about them, both developers, other security people, executives, anybody who needs to know about it. It's a kind of a recipe to follow for communicating vulnerabilities. And this was hard-earned knowledge. I spent, like I said, over 15 years doing this and teaching. I ran a consulting company and I taught all my consultants how to do this. And it's a skill, but it does take practice. And so like following this pattern will make you much more effective at communicating vulnerabilities and ultimately getting them fixed. Because, frankly, if you find something really cool, but you can't communicate it, what did you really accomplish? You might as well not have found it at all. So I encourage you to get good at this. It will radically change your career. The other article that I wanted to point out here was something called Making Security in a Software Factory. This is a real big picture article about how I think the future looks like if you want to target for what to aim your enterprise at in terms of how security fits in with the way that you build software. There's a lot of good ideas and knowledge in this article. So I'd love your feedback on that. Please, if you read it, give me a link back and let me know if there's anything that that helps you there. So with that, I'll stop. I think we got a couple more minutes for questions. I'd love to take any questions that you have about any of this.
Hey, Bill, Bill Kleinbecker, what was your point that you're trying to, as you typed in here, if you want to talk?
Yeah, who are the tiny ML people? Oh, the machine learning?
No, it's a group that's promoting edge computing.
Yeah.
It's Defense Department led. You can figure where all their applications could be applying applying the overall small, cheap, low power consumption type devices. And
Yeah.
every week they talk about either a concept of programming or about a chip that they've one of their members. The members are all basically the chip guys. I got a good friend.
Yeah, I focus mostly on web apps and web APIs because I think that's where the biggest risk is. But I will say there's a huge amount of effort going into serverless. And anybody who's interested in like aiming their career over the next 5 to 10 years, like serverless is going to be huge. I was talking to AWS recently, and I found out, you know how big they are. They spend half of their marketing budget on serverless. That's how big a bet they're putting on serverless.
I suspect that's the same case for the Department of Defense applications, because
Yeah.
they want to have this stuff on the ground. Your opening scenario where you're basically already got something out fielded, and you want to see if somehow it's been hacked. That's their biggest concern.
Yeah.
It would seem to me. I mean, obviously they want it to work, but you can't get it to work if it's been compromised. And you started also at the very beginning talking about being able to check what was done back in the manufacturing. The distance between the device being used in the field is far from the Lockheed Martins or whoever did a particular drone or whatever they're
Yeah.
using. So no, I think they're. If you'd like, I guess I could send you a contact.
Yeah, sure.
Yeah. Okay.
What else? What anybody got any takeaways? Like what stuck with you from the talk? I'm interested in feedback on what was interesting and compelling, if anything.
For me, what's compelling is you can fix it. You have 10,000 units out in the field,
Yeah.
and you can continue to monitor and fix it.
Yeah, I released a tool, a sort of a focused version of JOT just for Log4Shell right after that thing came out to help people that way. So, and they could just use a little tool and prevent that vulnerability from being exploited.
Well, another application area I can think of is going to be healthcare. Again, you opened it up talking about new diagnostic techniques from the same set of sensors. So they're going to want to have to. I mean, you could kill some politician based on not keeping that monitored continuously and do some of the techniques and for getting alerts it's been hacked.
Yeah, there's a good question here from a student at ACC. That's how can you use JOT to contribute to network security? Does it have use among network professionals who are not security oriented? And I should have probably said this, but JOT isn't really a security tool. It's just an observability tool. You can observe anything you want in an application. So let's say you want to understand the network behavior of an application. You could create a JOT that puts sensors on outbound socket connections, all of them, and very quickly figure out, what ports does something have open, which are listening, which are connecting, and understand what the code is doing to inform your network security exercises. I mean, look, I'm mostly an AppSec guy, so I don't like. I think mostly this is designed for development people, but there's certainly things that network security folks might want to know about what an application is doing, and this can certainly help. There's a question here about Java. It says, oh, this must be done in Java. Oh, yeah. So, yeah, I only created the Java Observability Toolkit. It'll work on other languages that run on Java, like Kotlin and Scala and other things. But generally, I would need to make a different one for like a .NET Observability Toolkit and so on. Contrast, our commercial product supports all the languages. We support Java, .NET, .NET Core, Node, Ruby, Python, Go, Scala, Kotlin, JavaScript, and PHP. So, we've got a pretty broad range of language support here. Yeah. And Jeremy says the big thing that stuck out was the level of effort once they're implemented. And I think that's right. It's really all about scale. And Michael Coates, who worked for me at one time and then became the CISO of Twitter and ran a bunch of other stuff, he said one time, it's all about scale. AppSec is all about scale. You could be the best pen tester in the world, but it's really hard to make a dent in a big company just doing pen testing. You're just kind of, testing on the margins. We need to test everything.
And hey, Jeff, we're actually at the top of the hour. So, I know people might need to go on, but thank you for doing this. This has been a great, I like the observability, the JOT, the injection into it, make sure that the Java code and everything else is getting observed where you can run through the tests. It's an amazing little open product there. Thank you for doing this demonstration for us and all the presentation.
Thank you. And you don't have to hire a bunch more people every.
I mean, my goal is to enable developers to do most of their security work themselves. And the role of AppSec people, like I said with my basketball coaches, right? Like the role of the coach changes so that mostly they're doing, the threat modeling, the architecture, the tool smithing, but they're not in the critical path to production. That's
It's
all
really,
automated.
like you said, driving a lot of the stuff that what AppSec people only think of basics is moving a shift left, moving it to the developer side because it's fundamentals. Like you said, the basketball dribbling, it's a fundamental. You shouldn't have a
Yeah.
coach have to teaching that stuff. They may have some teaching, but at the same point, there is tools that they can use to learn the fundamentals and let the coaching do. Hey, tweak this a little bit, or hey, here's the strategy we're doing for the game plan, things like this. So we're trying to shift a lot of that to the developer side and let them. We've done the heavy lifting of here's how you instrument now. You got to read what it's doing and interpret that and make that more straightforward. And this is a great tool for that. Thank you for doing this, man.
Yeah, I will one caution there. You do have to use different tools. You can't take tools designed for security researchers like SAST and DAST and shift them onto developers. That's not shifting left. I call that shitting left. Sorry.
Something left.
It doesn't work very well. It's just,
customers.
I'm sorry, was there a question or are we finishing up?
Wasn't sure that was a question either. Oh, somebody has a question. Is this impacting the open source development model? And Alexi's model evolve there as well? That was what Alexi was asking about.
Oh yeah, I mean, I think open source developers are generally not building full applications or APIs. Generally, they're building libraries, and they do build, sample apps to demonstrate how their libraries work, and then you can use this technique on them. There's no reason you can't use this on any code that runs. And real quick, while we're on the library subject, I will show you this real quick. This is a tool I wrote called JBomb. I just wrote this, within the last month or so. But if you want to analyze an application and get an SBOM, JBomb will generate that for you. You can do it locally, like I just did here. I analyzed it on the ticket book. So when we ran JBomb, it detected the process, attached to it, generated an SBOM, and then here's the actual SBOM that it created with all the components listed out. So you can generate an SBOM off of the running application, which is really cool. You can also do it remotely, like if I wanted to attach to a host, it will challenge me for my SSH credentials. And then do the same thing remotely and grab the SBOMs and bring them back to me. So that's actually pretty cool. I could use this to analyze a ton of different remote JVMs and get the SBOM. So if you're interested in that SBOM stuff, check it out.
Maybe sounds like another presentation there, Jeff. That sounds like a great one too. Because
I was thinking that too, because I could see a really interesting presentation just around this aspect of the tool. That's really cool stuff.
Yeah, again, this is a different tool. I made this because a lot of people are talking about JBombs, and frankly, if you're just analyzing that source code repo, you don't get a good picture of what libraries are in the application because they're not there. A lot of the libraries are in the app server or in the platform, and you don't know. Like the XML parser comes from runtime. It doesn't come from your source code repo. So if you want to know accurately what's in the app, you got to measure the app.
Thanks, Scott. Scott posted your GitHub location for your JBomb item. So yeah, someone found it and it's good stuff. All right. Well, I don't want to keep everyone too late, but thank you once again, Jeff. Thank you for doing this. Thank you for this stuff. And so there's potential right there. JBomb, another great one to talk about. But thank you everybody for attending. Jeff Williams, Planet Founder, Planet level there. And we will talk to everybody and see everybody. Well, maybe see everybody. We're still looking at for April, but April or March, I should say. So I'll see you all at the March 29th, I believe, the last Tuesday of the month. So have a good day, y'all.
Thanks.
Thank you.
Thanks, everyone.
Thank you.